curious about the location because that is somewhat important for Grafana specifically.
Okay.
Oh, and I want to point out that console is still considered as a single cluster from our perspective, from as it's a registry. We don't, in reality, console can synchronize data from multiple real clusters, and then can even synchronize data from multiple Kubernetes clusters. So we can have, it may be a bit messy when.
And that's the same for the VM expansion?
Mesh expansion, it's still considered as part of a cluster logically.
Right, exactly.
But
okay.
yeah, semantically, yeah, location may not necessarily be the same as. Well, implementation will provide feedback, I suspect.
Great. Thank you.
Okay.
Thank you.
Thank you. Yeah.
Should we move to the demo and leave the discussion?
That would be ideal, and especially the demo I think was added 2 weeks
long time ago. Yes. Okay. So let's move to the demo and then we'll have the discussions. Especially if we can compress it. Do you want to present?
Yes, please. If you could make me presenter.
Well, you just go to present, or I'll stop presenting, so it's easier. And no, sorry, not go present. Sorry, I'm in the meeting. In calendar, I think there is a link to the meeting, to Hangout, and I think there is a present button somewhere.
Yes.
You are.
Great. Well, thanks first for giving me the opportunity to share some work that I've been doing the last few weeks within the Federation V2 community. Let me first kick off the demo because it does take a few minutes to run. And while that's happening, I'll just kind of talk through the work here. Why aren't you going back here? Right. So first, I want to just take a few minutes to explain the use case that led me to this effort. And so at a high level, I'm looking at managing multiple Kubernetes clusters where there would be an Istio mesh in each one of those clusters. And for scale and all sorts of reasons, I don't want to share any state, if it's Kubernetes state, Istio state, across the clusters. So that essentially means each of those control planes, the Kubernetes control plane, the Istio control plane, is encapsulated within a cluster. And for production high availability reasons, I need to make sure that there's no single point of failure within the control plane. So no single control plane component can exist. Another key element of the use case is that I want to achieve a single kind of management user workflow experience. So I don't want to have a different workflow for managing my multiple Istio meshes. I want kind of that same look and feel, whether I'm managing multiple Kubernetes clusters, multiple service meshes, or multiple applications that either run on the mesh or do not run on the mesh within the cluster. And it needs to be simple to understand and start using. And of course, an open source approach that has a strong and diverse developer community. And that's what pretty much led me to Federation V2. V2's very different approach than the original Federation effort, but it is essentially two types of information that's needed for Federation configuration. The first is a type configuration, which declares which API types Federation should handle across all the Kubernetes clusters. And these API types can be native types, a config map, or it could be a custom type like a virtual service or a gateway. And then there's a cluster component, which declares which clusters Federation should target. And within the type configuration, there's simply three fundamental concepts. There's the template, right? So when you look at a template, it looks just like the standard manifest, again, using the config map example. And there's two additional fields in there, and the kind and the API version is different. But for the most part, if you look and understand a config map, you look at the federated twin of that config map, and it's very easy for you to understand. And with that template, there's also a placement type, again, that kind of marries that template with which clusters do I want this target type to exist, right? And then what's nice too is this third fundamental concept, and that's the override. So if we can imagine, okay, I've got 100 Kubernetes clusters, each with an Istio mesh in there, and maybe one of those clusters or a couple of them have some variations that I need to have differences in. Well, I can use the override type so that 98 out of the 100 clusters is cookie cutter, looks exactly the same, but the two that maybe I use for test dev, pre-prod, whatever it is, has some different configuration components to it. Let's jump back to the demo, and let me just kind of walk through what happened here. All right, have a simple script that first federates additional Kubernetes resource types. So when you instantiate the federation control plane, there is a handful of native Kubernetes types that federation federates, right? Again, config map, service, ingress, all that good stuff. And there are some additional types that need to be added. And again, federation provides that ability to add any types that we can essentially add to Kubernetes using CRDs.
So which lines there corresponds to a resource, and the federated is a prefix, no?
Exactly. Okay. So what you're seeing here, where I start installing Federated Istio, I mean, if you've installed Istio, which I'm sure everyone here has done a million times, it's a very same look and feel. The difference you're going to see is that, well, now instead of installing a config map or multiple config maps, they're federated config maps. And for each of these federated config maps, there's a placement type that goes with it. Again, simply saying, hey, here's the clusters that I want you to instantiate the target config map type to. And since this is a simple demo, I basically have 2 GKE clusters in 2 different zones. I stood up the federation control plane in cluster 1, and let me pause for a second just to explain, what is this federation control plane? Very simply, it's a controller manager. It's called Federation Controller Manager, deployed as a stateful set, runs as a pod, and it's just that has a bunch of control loops, very similar to the controller manager native to Kubernetes. It has an API. It's implemented by extending the Kubernetes API using CRDs. So a design approach that we're all familiar with. And then there is a command line utility called kubefed2 that allows me to go ahead and join clusters to the federation, unjoin clusters, or as you saw back here, federate additional Kubernetes types. So I can go ahead or either native or custom types, where I can go ahead and say, federate virtual service, federate gateway, and so going back to the installation, again, this is all familiar. The difference is, instead of adding custom resource definitions, we're adding federated custom resource definitions.
Can I ask a quick question?
Yes.
You discussed the fact that you can, from our perspective, one of the problems we are having is, how do we authenticate with each cluster? So you have 2 clusters. How do you store credentials? Where do you get credentials? How do you access the clusters?
Right. So for so for each of the clusters, again, they act independently. The meshes act independently. And so when I want to communicate with any of those clusters, I'm doing it the same way that I would normally do. I could set my contacts, my kubectl contacts, and authenticate against the Kubernetes API and start managing those resources individually. I don't have to, just because.
How is the controller, the federated controller or the pod that is running your federation? How does it communicate with the actual clusters?
Yeah. So what it does is when I do a kubefed2 join, where I say, okay, in my example, again, I've got two clusters, and the host cluster is cluster 1. It's hosting my federation control plane, but it's also acting as a target cluster. And cluster 2 is just my target cluster. And to your question is, when I join those clusters, cluster 1 and cluster 2, to the federation, again, I'm joining cluster 1 because it's also my target cluster, not just my host cluster. A component of federation is the cluster registry. And if you're unfamiliar with the cluster registry, simple API extension to Kubernetes, simple concepts that say, here's cluster 1, here's cluster 2, whatever clusters I join to the cluster registry, and it holds information about each of those clusters, simple metadata that I want to use, along with how do I access that cluster, right? So the API endpoint along with the TLS assets needed to access that cluster. And one of the things that that the federation control plane does when you go ahead and join the cluster, not only adding it to the cluster registry, is it will also go ahead and create a service account in each of those target clusters. And so it's going to use those credentials. It's going to go ahead and use those credentials to create the service account, secret, all that good stuff, right? So that it can securely access those.
That's what I wanted to get. Sorry. No, we are very familiar with the registry. I mean, we tried to use it in the past, and the main missing point was this service account and creating of credentials, because it has IP address of the other cluster, but it didn't have any way to authenticate with the cluster.
Yeah,
that was a request we had for a long time.
Yeah, and what you could see here, as part of the FedV2 project, there's, instead of having to manually join, there's a script, right, that does this, does the joins. And again, if you see here, this is essentially what that script is. I wanted to do this beforehand because I know I had limited time. So just, get my clusters up, get my federation control plane up, and walk through the Federated Istio bits. But as I mentioned, right, the Federation API, it's just a bunch of CRDs, right? And these are the native types, or the core API types that are supported when you stand up the control plane. But to your question here is, where is it at here? Right, we join cluster 1. We do some checks in cluster 1. We register them to the registry.
The service account, I see.
Okay. So, and we could talk more about that offline, but yeah. Let me go back to the demo here. Cool. All right, and it actually worked. Hey, so let me just go back to where I stopped talking. Right. So we finished the Istio control plane installation. I waited a little while for the control pods to run. What you see here is the control plane up and running in cluster 1 and cluster 2. I go ahead and then label the default namespace for auto sidecar injection. I check, and we see that for both cluster 1 and cluster 2, that's done. Now let's see if it's actually working, right? So I deploy the sample book info application. And again, for each one of these phases, I've taken the standard Istio manifests and just federatized them, if that's obviously not a real word, but you get what I'm saying here. And then let's see. So I check, make sure that they're running. They're not running just yet, but they will be. And then, okay, let's start testing it externally. So I create the book info gateway. a federated version of it so that I create those gateways in each of the 2 target clusters. I create an external DNS controller. If you're unfamiliar with this project, it is it's not part of Fed v2, but they do integrate with one another. And what it does is it simply just sits there and does a watch list against a CRD. The CRD that it's looking at is a CRD called DNS endpoint. And the Fed v2 controller creates this DNS endpoint, and all of that is essentially a DNS resource record. And it will go ahead and grab that information and then populate it in a DNS backend. In this example, I'm using Google Cloud DNS, right? So, so I'm basically taking my front end, the product page, and I'm exposing that product page out both of my clusters using the virtual service and gateway types of Istio. And then I'm going ahead and automatically or programmatically saying, hey, DNS provider, here's the IPs. And here's the DNS name that I want you to construct. Go ahead and create it so the rest of the world knows about it and provides connectivity across either of those clusters for that front end.
Are you using the one from Incubator? So
yes, absolutely.
Yeah. So very familiar with it.
I also have to go ahead and in order for, so one of the things that we can do with Fed v2 along with, it's not just that, it's really this whole kind of solution, right? One of the things we could do is cross-cluster service discovery, right? And if you're familiar, which I'm sure everyone is, how service discovery works within a cluster, same concept across the clusters with some, why does that do that? Let me actually just kind of show you here, right? So if I'm a pod within cluster 1 and I want to talk to an endpoint fs.ns.federation, if there's an active endpoint for that in my cluster, I'm going to communicate with that. If it's not, I then just start to kind of chain up the list until I find that that endpoint, and that could be anywhere else in the world, including cluster 2. Right, where I expose a service in cluster 2. And I'm not going to show that here, this cross-cluster service discovery in this demo. I actually just got it working yesterday. But this, I believe, kind of addresses the question that I've been getting since I've been socializing this work is, okay, well, how does service A in cluster 1 talk to service B in cluster 2? Similar concept, right? How do we do service discovery within a cluster? Well, we can do cross-cluster service discovery as well. And when we can do that, we can then start using Istio capabilities to identify the source and destination for doing rules and all that good stuff, right?
Actually, that's probably the most important thing for this group, at least, because that's pretty much the focus of what we are doing. Can you get a bit more details about how you synchronize the endpoints? Because that's the most important.
Yeah. Let me actually show you I'll just show you the manifest and how I do it. And then what I can do is the next call in 2 weeks, I'm happy to come back and really dive into that in more detail. Like I said, I just got it working. And so what I would want to do is document it and then just put together a simple demo script and a slide or two. But I'd be happy 2 weeks.
A design doc that you share it to be, if you can share it, some doc, whatever it is, that's probably better because we can comment and kind of prepare.
Okay. Yeah, absolutely.
Because that's kind of what we are doing today, and there are different proposals already on how to do this kind of discovery across multiple clusters.
Yeah, and so to that point is what we need to do is we need to create a config map. Both Cloud DNS as well as Core DNS have added this support, and we're basically explaining to those in-cluster DNS providers is here are additional zones and the DNS. The external DNS provider, if it's Google DNS, here's the name resolution servers, IP addresses of those name resolution servers, so that when that in cluster.
Oh, so you're basing it on DNS. It's based on DNS. Okay,
yes.
I got it. Okay, that's interesting. Okay.
Yep. And so basically, I after creating the federated domain and I create the book info service DNS record for product page, I'm good to go from the rest of the world, right? I've created the gateway, the virtual service. I've created the DNS information that I need to, and now the rest of the world should be able to hit my front end. And what the rest of the world doesn't realize is, this front end is in 2 different Kubernetes clusters running on 2 different Istio meshes. And let me just go ahead, and we see that, okay, it succeeded. And you see that it takes a little while because my client isn't pointing to Google DNS, so it takes a while for really for the propagation of the DNS resource record. But let's just do it manually really quick, and you can see that get a 200 back. I do, and let me share this with the group if I can do that somehow. How can I put it in the chat window?
You can add it to the...
Stop. Where's the chat window at? How about
on the top right, there's a chat.
Oh, yeah, here it is. Yep, no, I got it. Okay, there it is. Okay, there we go. So if anyone else wants to hit it, and let me actually hit it as well here.
So is it round robin between the 2 clusters?
Well, what it is because I'm using Google Cloud DNS. Google Cloud DNS uses multicast, and so if you're in Asia, if you're in Australia, North America, South America, right, they have their DNS servers spread across the world, and basically you're going to go to the nearest endpoint, right? And so it's not necessarily round robin.
Yeah, so your 2 cluster, are they deployed on the same? I assume they are maybe on the same region or?
Yeah. I mean, This is just a demo. So, but
Okay.
I've tested this with multiple clusters across the world, and yeah, it works. But for demo purposes, I've got basically US West 1A and US West 1B, so in 2 different zones. But yeah, you see here, it's like, let me know if you're having any problems, but you should be able to just.
Yeah, so you're basically relying, you're using, instead of EDS and the normal Istio discovery, you're using the DNS server, and you are relying on the DNS load balancing to do proper.
Exactly. Yes. Now, one of the things that I would like, and maybe I'm just not aware of this, because a use case that I started to investigate is how can we do live upgrades, right? If we have 2 or 3 clusters, each with their own mesh, and I say, okay, well, let's go ahead and use Fed v2 to say, okay, I'm going to upgrade cluster 3. Okay, everyone, move over your applications to 1 and 2, and that's very easy to do within Federation v2. You just patch the placement resources, and now those resources that I have running across, the 3 duplicates of the book info application are now just running on cluster 1 and 2. Okay, great. I've got no customer applications on cluster 3. Let me upgrade it, and now let's move that traffic back over. Where I started to run into some issues, and I actually saw it on the agenda here, is just an easy way from an Istio standpoint to, what resources need to be changed from a 1.0.0 to the next release, let's say. And so when we can get to that point where it's like upgrade manifests, I think that could be done. And back to kind of the original question is, what I'd like to be able to do is to instruct Google DNS to say, hey, even cluster 3 in this example that I just provided, let's say that's in Asia, and I say, Google DNS, even though I've moved all my applications off and I want to take that down for maintenance, and what I'd like to do is just kind of reorder the priority of the DNS resource records. So don't route it, even though my customers are going to Asia, reprioritize and send them to Australia or wherever it might be. Because what I have to do now is I would have to essentially take down the gateway, the Istio ingress service. And it's workable, but I would prefer not to take that hammer approach and take more of a kind of a surgical approach. One last thing I want to demonstrate here too is, right, so this is pretty cool. We've got multiple instances of the book info application. No one in the rest of the world realizes that it's highly available. But what I want to do now is I want to go ahead and I want to use the power of Istio to say, okay, right? We've seen this demo on same thing, but now we're doing it across multiple clusters and meshes. Is, hey, route all the reviews traffic to reviews v1. And again, I've federated these route rules. So I don't have to go ahead, again, if we had 100 clusters, 100 meshes, I don't need to have 100 different instances of the route rule. So I can do create Istio v103 samples, book info, routing, and it is the route rule all v1. And this is, again, it's just like the route rule all v1 that everyone knows and loves, but it's the federated equivalent of it.
So when you say federated equivalent, does it mean you have to change every single gateway definition, every single virtual service and destination rule to be federated manually?
Here, let me just take a second here and show it to you. Here we go, book info, routing, all v1. This is exactly what I went ahead and did, right? And so what you'll see here is, well, the virtual service looks just like the normal virtual service for each of these, but it is a little different, right? I'm now using the federation control plane by saying, here's the API that I want to use. And you see that it's no longer a virtual service, but it's a federated virtual service. But really, the meat is still the same. There's the difference here, right? Instead of spec hosts, it's spec template spec hosts, right? And then for every federated type, we need to tell, okay, where do I want to go ahead and place this? And that's the federated virtual service placement. So it's that placement type that says, here are the clusters. And again, okay, this is interesting, but imagine the cluster names being 1 through 100, right? But for the most part, it looks very similar. So what I have found personally is that it's easy to ramp up on the federation, on how to federate resources. Now, with that said, it was also very painful and error prone and all that kind of stuff to manually do this. And since presenting this, because I've been working within the FedV2 community for the last 2-3 months on getting us to this point, is actually creating a tool, and it probably won't be a separate tool, but it'll be a kubefed2 federate command that ingests a standard manifest and spits out the federated equivalent of it. Because really all it is changing the API in kind, creating a associated placement resource for that, and then adding the spec template. And then one last piece that I'm not demonstrating here is, if you recall, there's also the override type. So I could have a federated virtual service override, where if I did have 100 clusters and say, hey, let me create a federated virtual service override, and for cluster 99 and 100, I want to go ahead and change the some component of this template here. Now let me just kind of wrap it up by saying, okay, if everyone refreshes.
Yeah, I guess we don't have visibility. We really don't know which cluster is being hitting.
Yeah, well, it's fine.
Yeah.
Yeah, I mean, what you can do if you wanted to is you just do something. I believe if you dig it, you should see
IP
here.
address. You can get the IP address if you look at probably the detail info or something like
Yeah,
that. Get the IP address to see which one.
Yeah.
Few comments, if I may. One is there are some pieces that are extremely useful in this demo. I'm very interested in the authentication part, because it will be good to align with what we are doing for multi-cluster. And I think we have a similar approach. We also create a service account. We also connect to the other clusters. The main difference seems to be that you are using DNS and we are using envoy-specific API, which is important for us for load balancing other purposes. So that's kind of interesting how. I mean, it's remarkable that we got it working with DNS, but I think we'll probably need still need to use EDS and for the weights and for the other features that it provides.
So Daniel, I have a couple pieces of feedback as well. I see 3 things kind of in the similar. You've optimized the multi-cluster install. That's fantastic.
Yeah.
The CRD federation, I think, is interesting. And we could use that as long as it doesn't result in a change of the APIs. And then I think the third thing Costin kind of alluded to is there's a lot of contention around how to do discovery, and we sort of have a solution in mind that scales really well. So we'll have to sort that out.
Yeah, and keep in mind, again, the use case, and I realize at least what I've seen so far is this multi-cluster, multi-mesh. It's just a topic where there's a lot of different views and different approaches. And I think as this space matures, we'll see, what approach kind of floats to the top. But going back to kind of my use case is that this pattern of how to manage and use, it needs to be a consistent workflow, whether it's for Istio or non-Istio, right? So if I go ahead and say, I want to go ahead and just stand up a high availability application on Kubernetes, I could take the same exact workflow. And so just keep that in mind from my use case standpoint, but whatever I can do, however I can work with the community, and just at least to, again, I'm not saying that this is the right or only way to do it, but I think it is a viable way to, a viable option, and it's meets the use case that I described. So anything I can do, to make sure that we're working together and not against each other, I'm all ears.
No. I think we are all looking to see what we can reuse and how we can make everything fit together with what we are doing and with all the other. Try to find something to make everyone happy, basically. And
what I'm showing you here really quick, and this is what I would come back 2 weeks from now and just demonstrate a little bit more, is I've got, again, the 2 clusters, and each cluster I've got the HTTP bin sample app, that's my server, and then the sleep sample app, that's my client. I use Federation to deploy both of them. So all the same stuff we just saw with book info. And again, I'm using standard mechanisms of Istio of create the service entry, create the gateway, create the virtual service, and then again on the Federation side, I create a domain from the DNS standpoint, and then basically connect DNS to the appropriate Istio component, which is the ingress gateway. And I've tested and verified that I can have sleep clients communicate to each other's cluster's HTTP bin app. And again, I'm not just using standard Istio mechanisms. It's just a federated version of those mechanisms.
Yeah.
Do you have an example of your installer? When you install and you deploy Istio on all clusters, you said you have some templating capability. Can you show us one of the federated YAML files or whatever you use to deploy pilot and everything else?
So when I go to Istio 103 install, this is so what I did is I took the source of 103 and I ran the Helm template, right, to generate the manifest. And then at this point, it was a bit taxing, but created the federated equivalent exactly as you see it in the standard Istio YAML. Now, one thing I did, let me pause there for a second, because one thing I had to do is I did have to break off in 103. I didn't see this prior to 1.0, but in the standard manifest, there is these custom types that get called. And so at the very end of the manifest, I had to take those out, because one of the things that I have to do is I have to federate those, right, using this kubefed2 federate command, right? And so I had to do kubefed2 federate enable let's see, the Istio types, the destination rules and all that kind of stuff. Otherwise, Istio YAML and Istio types YAML, you combine those and it's the same exact thing that you'd see from a standard install, with the main differences being API versions change because we're talking to the Fed v2 control plane. We add federated to the standard type. And again, we have to add spec template and then the associated placement resource. And again, this was...
Do you have any templating inside this config? Did you add any templating, any way to override or to put a cluster name, for example?
Not at this point. This is work that literally is kind of like hot off the presses. So, my focus was, okay, let's just socialize it, right? So last week, I formally presented it to the Fed V2 working group. I've been working with them. They've been awesome to work with and have been huge supporters of this effort. But yeah, there are some issues, and I probably have 10 different issues, primarily in the Fed V2 working group, but in the Istio docs, in Helm, as I came across ideas on how to improve and where do we take this to. So templating, we're looking either internally within the Fed V2 group on how to just automate this, right? That could be kubefed2 template, right? Where again, we ingest the standard Istio YAML, spit out the federated equivalent, so I don't have to do this again manually because it was painful. Or looking at the Customize project, could we use that? And then whether we do it internally or through Customize, is then take that and then can we bring it into Helm so that there's a Helm ability to, instead of just creating a standard manifest, we can create the federated version. And then if we have that tool, I'd like to bring it into Istio end to end, so that whenever we build out and there's a YAML, we can create the federated equivalent and then run the end-to-end tests in a federated manner as well.
Yeah, so I think that I have two concerns with this approach. By the way, really good demo. So my first concern is, I think if I install Istio in single cluster, and based on and if I have booking flow running, and then based on your YAML file, I think I would have to reinstall Istio for federated, and I have to re-engineer my booking flow and all its configuration YAML to be federated. To work with the federated mode. Is that standard practice for the federation community, to ask people to kind of re-engineer everything, maybe reinstall everything? So that's my first concern. My second concern, I think Shauna shared too, using the DNS cloud service. Not every single cloud probably have DNS cloud service. So relying on that could make the solution to be cloud dependent.
Okay, let me respond to question 2 first. So what I demonstrated was an example implementation. And one of the components of that I briefly described was the external DNS project that supports multiple backends, right? And I don't know all of them off the top of my head, but I'm pretty confident that one of them is core DNS, right? So it doesn't have to be a cloud DNS backend.
Okay, that's
okay.
Cool.
Yeah. So you would just stand up. You would stand up, let's say, a core DNS outside of all the clusters in your standard data center, or multiple of them, and load balance to them, so you can kind of replicate what I'm doing with Google. Back to your first question, and I'm not sure if I captured it entirely. Is
So maybe I'm missing something. I'm looking at your Istio YAML and also the book info configuration for gateway and the config map for Istio. Sounds like this is different than what the standard Istio, if I install Istio within the single cluster. So I'm thinking user must start with cluster 1 before they even get to cluster 2, right? Let's say if I start with cluster 1, I install Istio, I got my booking for whatever app I have working. Now, when I want to go to federated, do I have to reinstall Istio because the federated Istio.yaml and also the booking for gateway and virtual services are totally different now?
No, not at all. I mean, if you have 3 clusters and you say, well, cluster 1 is up and going outside of federation, I don't want federation to touch it, then we would use placements and say, hey, let's create a federation, but let's not even touch cluster 1 just yet. Let's just do 2 and 3, and then the cluster names would be 2.
I want to upgrade cluster 1. I assume. Okay, so you have the capability not touching cluster 1, but what if people wants to upgrade cluster 1 to be federated?
I think it's perfect segue into the next topic, Lynn, because we have exactly the same problem with Istio 1.0 to 1.1, and we just have 10 more minutes to discuss. So
okay.
Oh, so you would expect people to upgrade from standalone Istio within the single cluster to federated Istio?
I mean, I think it's worth more.
1.0 to 1.1.
I think it's more of a discussion, and I think if one approach would be, if that I would consider is, okay, let's take the 3 cluster scenario. Cluster 1 is standard. I stand up federated control plane. I say, okay, let's federate 2 and 3. Istio is running, my same applications in the non-federated cluster are now running in 2 and 3. And then I'm going to just migrate over and say, okay, we're going to upgrade cluster 1, essentially upgrade it, but add it to the federation. And then I would add it to the federation. And to do that, I would take all those manifests of Istio and any of my applications running in cluster 1 and federate those manifests, right? And again, what we're looking at doing is one of the main next steps is having a tool that makes that easy.
And actually, the funny thing is that that's exactly what we want to discuss for the next topic,
okay,
which is amazingly that similar. Let's discuss the upgrade for Federation next week or sorry in next meeting. Because probably there'll be other topics, and I appreciate more details in the document about where exactly the service accounts are stored and how the DNS sync is working. So let's move to the next one, which is exactly what we discussed earlier. How we're going to deal with 1.0 to 1. We have how are we going to deal with the 1.0 to 1.1 upgrade? And the CRD problems. Steve, do you want to?
I wanted to pick it up, Carsten. I mean, I think pretty clear we know that CRD install doesn't work and probably won't work ever for us. And we don't want to rely on advanced implementation details of Helm to do our work. So because of that, we need some kind of workaround. I think you had the best solution, Carsten. So maybe you can propose what you had worked up and we can go from there.
Well, what I have is, it was intended for 1.2 or 1.3. I mean, it was more like just like federations that we discussed earlier. It was more long term than quick fix for 1.1. And it's actually, again, I'm surprised how similar it is to what was described earlier about the idea that instead of upgrading the component as a whole and just saying that, you know, I have Istio pilot running and I'm going to upgrade to a running upgrade. The model is also that, hey, I start the new Istio pilot in a different cluster, different namespace, different instance anyway. And then I gradually migrate every workload to use a new pilot. And then I shut down the old one and I'm done with it. So the approach that I try to take in my prototype is to break down the components so you can run multiple namespaces with different versions and configurations of each subset of Istio components. So telemetry, for example, will run in a namespace. The telemetry 1.0 will remain in Istio system. You start telemetry 1.1 in a brand new namespace. You start pilot 1.1 in a different namespace. You start a sidecar injector again with 1.1, and then you relabel all the workloads to point from Istio system to Istio pilot 1.1. Istio pilot 1.1 will point telemetry to telemetry 1.1 and so forth, and everything will kind of migrate, but one namespace at a time. You may
it's hard to remember though.
It is a bit hard to remember. Again, it's something that again, it can be scripted. I mean, if you want to live dangerously, you can just run a script that is just creating everything at once. It's still a script. But if you are a bit more, production oriented, you probably want to have this kind of safety net where you know that you just migrated one namespace, maybe not the most critical part of your business. You migrated it, you see that everything is working, you see that again, you don't have any kind of failures, errors. If you see any problem, you roll back and you are not kind of putting all eggs in a single basket.
So you are expecting to coexist between
that's the main point.
and the new version in different.
Yes, coexistence is the main goal, and it's not only migration; it's also at production time. You may have some production workloads that are running with default MTLS enable, with whatever resources policy and so forth, and you may have a bunch of other test jobs that have different requirements. Where you want to have by default logging enable, you want by default to have policy turned off, or you want to have more metrics. You have different profiles or environments. I'm trying to call them environments because it fits the working group meeting. And you would have one pilot in a different namespace for each environment. And one of the environments may be Istio master with all debugging on and everything, NTLS off. You have the production environment where everything is locked down and it's the most, and different resource allocation, different everything. So by pointing a particular namespace and workload to one of the environments, you get a particular configuration that fits that particular needs.
So, Costin, can you give some background to what this is actually addressing in the current approach? Like, what is the problem with the current approach?
Well,
the
current approach, an upgrade, when you upgrade Istio system, it's a all or nothing. You start the upgrade, and then 5 minutes later you see the entire cluster goes down because you may have a bug or a mistake or something is wrong. And that's the problem. And also you have only one set of defaults. I mean, you configure Istio system in a particular way, and that's my way or the highway. You don't have any way to kind of or any easy way to customize. You could do QB inject and modify the debug. For example, if you want logging in one particular namespace, you want debug. Good luck with that. I mean, you need to use QB inject, and then you need to tweak the template and do other things. You don't have a way to easily set a particular profile on your namespace. And also, it's the values.yaml that we have. It's a nightmare. I mean, we have 100 and so values that are nobody, I believe, understand each of them, where it goes and what it does, and it is still used.
Can you explain the specific problems from upgrading 1.0 to 1.1? How this addresses that problem?
Oh, accidentally it addresses the problem. So the problem, as Steve put originally, is that if people install with Helm 2.10, Helm 2.10 has a bug and it will not allow us to create additional CRD. So if you modify the CRD, the types, they will be stuck in 1.0.
So you had to delete the old CRD and put
no.
the
If you
new
delete
one.
them, you delete all then we delete all the actual configurations.
Oh, right.
Yes.
So all the virtual service gateway
Yes.
will be gone. Yes.
Yes.
So when there's actually no workaround for this except to maybe create an operator that creates the CRDs at runtime. And a short-term workaround we could do, and I think Costin.
Or a long term, I mean, we do want to have an operator. In long term, we want to move away from Helm because we keep hitting Helm problems, and we want to move to a model where more and more can be automated in operator. So that's and it can be a simple script, like I think what you have there, but it's also kind of moving to a split because we have ordering. I mean, if you start in a different order, you are kind of likely to hit problems when you upgrade.
Mm-hmm.
So.
Can we
So
separate
that's
this specifically for 1.1? So
I think it's a great idea, Jason. I think we need to have the short term and kind of the medium term. And Costin said his work was for 1.2, right? So.
Oh yeah, absolutely. But I think we are kind of aligned, and we are all heading in the same direction of breaking up the monolithic installer in at least 2 components for 1.1. I mean, in your PR, you are taking out the CRD creation and create a completely separate chart for CRDs only.
Mm-hmm.
And that solves a lot of problems, and operator is having the same thing.
So what problem would that solve if Helm doesn't allow you to upgrade CRD? So are we saying for that piece, you are going to use Helm template to do the upgrade yourself?
No.
You could use either model, but if you've done an install with Helm 2.10, you cannot upgrade. If you've not done an install, there's an upgrade path. If you've used an earlier version of Helm, there's an upgrade path without, because the PR removes CRD install. So that's basically what the PR does, is it removes all usage of CRD install so we can add CRDs later. I don't think it's the right approach, though. Actually, after thinking about it, I think the right approach is to make a process that creates a CRD at runtime. That would be compatible with CRD install or not. And we could leave the CRD install as is today, and add new CRDs on the fly in our kind of operator thing that's very simple and straightforward that creates a CRD.
Oh, see. So the operator will be in charge of updating that CRD for you, so your configuration still be around. Gotcha.
Right on.
Yeah. Is anyone aware of just like the manual steps to go from one version to the other? Has anyone completed that and documented that at this point?
We are aware that it's broken, apparently. That's the only thing that we
and what I would be looking at is like Helm aside is just like, okay, right? What resources need to get patched, or which one, which new resources are added, or what configuration, all that kind of stuff. And that's kind of the process I started going down a couple weeks ago when I was trying to do what I'm calling, Istio live upgrades. And I saw, as I started going down there, I'm like, oh wow, there's a lot of things that need to change. And I'd be interested in helping, potentially creating either an operator or just essentially a controller that can do the upgrade. But the way that I do things is like, okay, first let's just get it down manually, right? How do I go from 1.0 to 1.1? What things change, and do it manually, capture that, and then automate it with a controller.
Yeah, I think we know that, but it's probably not written down. It's probably in people's heads, which is probably not the ideal place for it at the moment.
Because even from from a user standpoint at this time, is like, okay, yeah, maybe it stinks that I have to manually do this, and I could create a simple bash script eventually, but until we have something that programmatically does it, at least that's an option to say, hey, here's issue XYZ, we're going to automate this, but for the time being, go through this painful manual process, and maybe we even just create a simple script to help out in the near term.
You could even break the operator up into steps. So there's the CRD install,
right?
Because what we need for 1.1, and then the more exhaustive exercise of enumerating all the resources we have. It's going to take a lot more time.
I think the proposal is exactly that, Jason, to have a small micro operator, or however you want to call it, that is only responsible for CRDs. And again, the patch that is proposed is kind of doing that. It's just basically, well, it's a script or whatever it is that installs the new CRDs independently of the rest of the installation.
We would need a two-step process with an operator, right? So
yes.
So if we have a two-step process, why wouldn't the manual scripts? But why couldn't we use a two-step manual process?
We can also do a two-step manual process as well. Yes, it's true, but again, it's not the most convenient, and it's not going to. We don't want to. I mean, we want to move towards solutions that will work in the future. Where I mean, if we know that we are going to move to a operator and a multi-step process.
I totally agree with the operator and everything you said. I've been a long-time advocate of that. I'm just looking at the timelines for 1.1 that we should be frozen now. And so if we are implementing a new component at the last minute, there's risks.
One or another, we need a new component that is doing this. I mean, it's a manual script, it's whatever it is. It's going to be some things that will need to be tested, and in the three main scenarios that we have people installing Istio 1.0.
Yeah, otherwise, I mean, the alternative, Jason, is we leave people without an upgrade path, which is not ideal. And I'm not.
No, it's not acceptable to not have an upgrade path. Yes, that's clear. I mean, it's
So once
the manual approach will work. So
once you separate the CRD out, can I use Kubernetes replace to do in-place upgrade of my CRD and not removing my existing configuration?
Yes, that's the goal.
Okay.
So is there this, let's call it the Istio micro operator, is there a prototype of this as of yet, or is this just kind of discussion at this point?
I would call, a script that is doing the creation of CRDs as a micro operator. That's the first draft of micro operator.
Right, and you can do it manually too, right? Sounds like I can use Helm template to manually generate the new CRD for 1.1, and then I can do kubectl replace -f to apply the new CRD. It's just you can't do it through Helm because it's messing up.
Where does this script, really quickly, where does this script exist? I'm just interested in learning more about
there's a PR in the notes, Daniel.
Okay, got it. Cool. All right.
Okay. We are getting kicked out of the room. We'll discuss probably next week, or probably on Slack or email, because
not
it's more
on
urgent.
Thanksgiving, the week
not on Thanksgiving. Yes, sorry. The week after. Okay.
Okay.
Bye.
Thank you, guys.
Sorry.
Bye.